Hi guys, just a quick brief introduction to fragrances because you'll have heard me prattle on already to this afternoon and Mr. Hayes. So, learning outcomes, overview of essential oils, what they are, what they're used for, what makes them up is terpenes. Now, I've written on the slides where you don't need to take a note. Read through them, nice history, nice information, but not essential. But obviously what they are, they're evolved to do with perfume and scent, that sort of thing. So lavender, but there are also lots of other uses. So when you get to this slide, I would make a wee table of it or notes of, kind of uses. There's a little bit more detail in the uses further on, giving you some information about each one. But again, you don't need to know the names or the structures. That's what I've written up there. Then just further on, more information about uses, and you look at the structures, and it's not necessarily, you don't need to draw the structures out. You need to be able to recognize different things on the structures. Oh, look, there's a carbonyl group. Okay. Steam distillation, if we were in class, we would have been doing this. So you distill orange peel, pine needles, that sort of thing, to get the essential oil out of them. Different boiling point from water. There's a wee video there you can watch all about that, and there's questions there you can answer. The answers are on the next slide. Then we go on to the terpenes. Now, terpenes make up all your essential oils. So it's the structure that they make, that the essential oils are made from. So again, I've put no need, but it's quite nice to know, the kind of terpenes that are present in these essential oils. Now, terpenes are made up of an isoprene unit. Now, an isoprene unit is you will need to know the name for this and be able to draw out an isoprene unit. Now, if you think about it, it's 2-methyl-butyl-1,3-diene. So 4 carbons in a row, double bond off the first and the third, and a methyl group off the second. So it's C5H8. So when you're given a long structure, you need to count the carbons. If there are 10 carbons, then there are 2 isoprene units present. To join them up, you can join them up so they become a long, here we go down here. So head, tail become linear terpenes, or you can make them circular, as we'll see in these ones here. So sorry, that's like a bit wobbly, but if you count the carbons there, you're going to have 2 there, and that's a linear example. Whereas here you've got 2 isoprene units, one red and one blue, but they form a circle. And there's lots of examples here, so it's quite nice just to go through them and have a look. Again, you do not need to have take notes of them, but it's just nice. You do not need to know the names or the structures, but you need to be able to recognize how many units of isoprene units are in each one. There's a wee summary at the end there. Okay, so that's that.